here. We're trying to replicate this. So what we've got going on here, I got 30 volts on an open ground neutral on a GFCI here. So it's correct wired. And you're going to see we hit test. It's going to trip it because this plug tester takes a minute. So this is a plug tester here. There's nothing wrong with this plug tester. We've tried 3 other plug testers. 30 volts on the neutral still. So when we hit test on this one, and when it resets, it doesn't show the red light. So we're going to try to figure out how to replicate this issue where we've got 30 volts on our neutral, open ground neutral. This is after the GFCI is tripped. So we reset this thing, and you can see we have the correct lights. So I'm going to bring this up. I'm going to be able to see the chat in the screen here. I'll try to keep up with the chat. But we're going to be wiring some stuff wrong purposely to see if we can replicate what's going on. That's the idea. So you've heard the term, you know, fail upwards. We're gonna wire it wrong until we succeed. All right, what's going on, Shrush? How's it going? Okay. This is our power here. It comes straight up, and it's going to go directly to a receptacle. So it's not tied in. Nothing is energized yet. The thing about energized work, man, there's really only one situation where you should ever do energized work. And that would be where there's more of a danger to turn the power off than not. So a hospital where patients are at risk is probably the only situation where you want to be doing hot work. Infrared is another one because you can't see the heat without the power being on. So with infrared, you have to turn the power on. And then like data centers, that's like like YouTube's run on a data center on a server. Can't turn YouTube off. So things like that, 911 call, dispatch, things like that. Never ever do hot work. There's no excuse for it. Doesn't matter how much PPE you have, how much experience you have. There's no excuse to do hot work. Now, testing is a different story than hot work. So when you go to test, sometimes you need to leave the power on. But when you're in a testing environment versus like an install environment is a completely different situation. So in this situation, we're going to be in a testing environment. Things are going to be energized, but we're going to be using our testing instruments only. We're not going to be putting tools on this stuff energized. We're going to be using testers. So no hot work unless absolutely necessary, and then testing purposes like infrared or this. So we're going to tie this into here illegally. All this is going to be illegal. Don't do any of this at home or especially at a customer's house. Yeah. So what we're going to try to do is we're going to try to backfeed a GFCI. So we got our GFCI here. I want to test this out. A lot of people say this won't trip, or it will trip because it's sharing a neutral. But I think if we feed it with a shared neutral and it sees the shared neutral coming out, I don't think it's going to trip because these usually measure the difference and then trip the circuit based on the difference it finds. If we start off with the difference, I don't think we're going to be tripping the circuit. So for this, we're going to be using grounds, but we're not going to be bonding our boxes because if we accidentally touch a hot to the ground, there's going to be a spark. The boxes are floating. There's no potential. We're not leaving this energized forever. We're going to be hooking up the grounds to the GFCIs and our devices properly, but we're not going to be bonding our boxes because we don't need to in this case. For something permanently installed and not in this situation, we definitely want to be bonding our boxes. So we're literally just going to take some wire nuts and just start installing this. In general, you can't cut the cord cap off of anything and hardwire it, or cut the cord cap off and add a cord to anything unless it's listed for use with a cord. But in this case, for science, I suppose. So, got some big blues here. And we're just going to take the ground the same way. Might even Wago the ground. We're going to wire nut the hots because, I mean, come on, wire nuts are definitely superior. And we're not able to grab. We got to slide that up a little bit more. There we go. All right, I'm going to check the chat. So what we're trying to do, we're trying to send a stray voltage from the neutral back through the line side, I think. I need to draw it out to get a good picture on exactly what we're going to potentially achieve here. I'm going to switch this wire nut out because it seems like it's going to be happier with one of these. It is. Okay, so now we can plug this in. We're not going to right now, but we can. Let me check the chat. Do you collect and cut up wires from devices that's been thrown out as garbage? Hey, they're hiring electrical helpers in your general area. Impact driver to unscrew something. Why blue? All right, so this is a test video. Since you just got here, I'll show you what we're doing one more time. So the short is that if you go look at one of the shorts, I'd have to switch up what I'm doing here, but basically we're getting a ghost voltage after we trip the GFCI. So we're getting 30 volts after the GFCI is tripped. This is a driver, not an impact driver. It does not impact. And why blue? Because it's what we got here. All right, so I guess the next question, I'm an electrical inspector, so I see this stuff all the time. This is the first time that I've ran into this situation where we had 30 volts on the neutral after we tripped it. So everything was cool. It says that we're reading the voltage properly, and then when we trip the GFCI, we get 30 volts on the neutral. I suppose I can show you that short again. Let me show you. I will go back to where I was here. Hang on. Let me go to my shorts here. And here we go. Okay, so what we got 30 volts, open neutral ground, right? It's not the tester. The tester's, nothing's wrong with the tester. This is the third tester we tried. We got 120 volts normally, and it's green saying correct. When we hit test, this tester goes through a cycle. And then once it's done, now it's going to display fault. And it says 30 volts, open ground neutral. Then we tested it on a regular GFCI and didn't get the same result. So something's wrong with that circuit. We're seeing if we can replicate it. Let me go back to where I was here. Hang on. Because I need to be able to see the chat. Perfect. I knew we were going to get an ad. Okay, so my theory, I'm in driver, why not a drill? That's just what you use. It's quicker, you don't have to chuck anything in. Electricians don't use drills unless you're really drilling holes. For the most part, you don't need a whole bunch of torque. This is what we're trying to replicate here. Let's see if I can stand you up here. I think, let me get my margins here. Okay, right there. And then there. Okay, so that's the box you guys can see, and this is where I need to draw my diagram. I think what we want to do, we're going to put a regular plug here. And we'll draw the hots here like this. Blue will be neutrals and grounds because we're not hooking up grounds until, well, we're not going to show it. And then we're going to go to a GFCI here. And we know the GFCI has a line and a load. So what I want to try to do, we're going to feed with a cord, unfortunately. Right? You can't see that cord probably because I drew it out of the box. There it is. Got the cord there. We're going to feed a lamp. I've got a lamp here that we can turn on, and then we can check the amperage with it. We're going to feed a lamp into the line side of this. So I'm trying to figure out how do I want to do this. We're going to feed the line side of the GFCI. Yeah, I don't think the load side of the GFCI is even a factor here. I think we're dealing with the line side only. So this is a regular plug, right? And then this would be a GFCI. And what we want to do is we want to introduce some amperage. We want to introduce some amperage. So if this is, hang on. Do that kind of backwards. There we go. Line and load. We're not going to be using the load side of the GFCI. We want to take this plug here and put the neutral in series here. This is where the neutral amperage is coming back. We want to put, I think this is what we want to do. I think we want to use the neutral here like this. Man, I'm trying to figure this out. We want to get the neutral on the line side of this GFCI feeding from this lamp. We might not be able to do that. Let's see here. How are we going to do that without cutting this cord? We're going to do it on the receptacle side, I think. I think we can do it on the receptacle side. Never used a driver until I bought my rental property and started doing handyman stuff to a house. Nice. Let's start getting this together, and then we're going to figure out how we're going to see. We need the amperage from this cord. We're going to do this a really ghetto way, actually. We can do this. This is actually going to be so ghetto. I don't recommend you do this. And it might be hard to understand what we did. We are going to split the hot and the neutral off of this cord using a receptacle backwards. And then just feed the GFCI. That's what we're going to do. And it's going to be weird. But yeah, that's what we're doing. So we're going to plug this in. And we know that the big one is the neutral, right? So the big one's the neutral. That's how you check the polarity of a cord too. You know, the skinny one right there is the hot. So neutral goes in there. Now we can check the amperage of this light. If we were to plug this in, we can see the amperage of this light. We want to feed the GFCI with a load. That way there's always amperage. And then we want to attach the hot, not to the hot of the GFCI. We want to attach it somewhere else, I think. So we're going to kind of wire this weird purposely to figure out, can we give the GFCI line side a voltage even when it's off, or some kind of potential, I guess you would say. Let's do it. So if we take our wire here, let me tighten this cable clamp. It's kind of bugging me. That'll work. That'll work. Okay. Now we're not going to strip all this off because we're just trying to get to what we want here. It's going to look more ghetto here in a second. Don't worry, I assure you. Okay. We're not going to be hooking up our grounds because if we give this thing a potential, it's just more trouble for us. So we do need the grounds for the GFCI to function and everything. So what we're going to do, we're going to introduce an amperage into the line side of the GFCI for starters. So if we go to the line side here and we strip this out, go to the line side of our GFCI. And I preach on this, but we're just doing temporary. We're bumping it half a turn. We're not even using an impact. Okay, we've got the line side. Now we're going to take, we're going to backfeed this device. So this is going to be the return path to get back to the source. So this is going to have power from here. And then this, I'm trying to think about this. We need to get, yeah, we can get power from there too. And then when we plug in this device, we should have current on this wire, even when the GFCI is off. That's what we're trying to do. We're trying to put current on this wire and see if we can detect it. So this should do it. We should be able to put both of these hots in here like this. And we should be able to put both neutrals in here. And then once this lamp turns on, we should have current on this wire going back through the line side, even though the GFCI is off. That's what we're trying to do. Because I think that's what these guys did at a job. So we're going to check it out. And for this, we're going to use Wagos or something. Oh, we got some ideals. I actually like the ideals a little bit more. They're actually rated for 450 volts, whereas the Wagos are not rated for the voltage. Are they better? I don't know. Wago's been around longer. I really, really like how these snap on. And they don't really seem to want to lift up. I like the ideals is what I'm trying to say. But I think wire nuts are better. Okay. Strip that off. I'm going to strip a little bit more, just for good measure. And we need to strip that too. I'm going to plug this in here. Plug this in here, and we need our GFCI to also be plugged in to a hot coming back to here, because we need to feed the GFCI with a hot. So let's get one more wire. Okay, here. I'm gonna check the chat here in a second. We're on the line side of the GFCI, so we're trying to load up the neutral. Come on, screw. Man, usually they spin. There we go. Look the other way. We're not using an impact. We're using a driver. But I still don't recommend putting power tools and things like that. Okay, so we're gonna go in here now. Our hots are now hooked up. Our neutrals are technically hooked up through the line side of the GFCI. So we've got current flowing on this wire here. Not a normal install. Usually you would not do this. Don't ever make this assembly. This is what we're trying to prove is wrong here. And we need to hook the ground up to the GFCI, and I'm also going to hook the ground up to our receptacle here. So let me get a ground here. All right, I got some ground wire here, and I'm going to guess right about here. We're just going to bare the wire in one spot. There we go. Do not do this at home like this. So ghetto. Okay. Got our ground landed. We need to land our ground here to the GFCI. And we need to give our ground a reference. And we're not hooking up the box purposely, guys. That way, if we energize the box, nothing happens. Just going to use this piece of crap blue wire nut because I found it. First thing I grabbed. Okay, now we need this neutral to be the source. So this neutral also needs to go to this GFCI, I believe. And then we should be able to plug it in. Let's see what happens. Nice. So bad. This is so bad. Okay. GFCI here. We got our plug here. What we're going to be able to do, we've got a lamp up here. It's an LED lamp, so we're not going to be able to read too much current off of it. But I've got a line splitter with a multiplier of 10. So we should be able to read something off of it. I'm going to plug the lamp in here so we can see this plugged in at least. There we go. We're going to turn it on now and see what happens. And I'm also going to check the chat. Let me see here. American plugs look like little shocked faces. Yeah. Wigos, what's up, Jamie? These plugs look different than what we have in India. Their connection side is more exposed. And now this is the wrong way electrician channel. Yeah. That's awesome. Okay, I'm going to plug it in. And let me see if I got a plug tester or a hot stick or anything here. I think for safety, we should already have this plugged in, so I'm not unplugging and touching something that's energized. Oh, we'll also get a nice readout here if it's... Oh, we have a GFCI tester here. Now, oh, well, here's the thing. The internet is on... Is this circuit? No, this isn't GFCI protected. This circuit that we're using is the internet. So if we trip this circuit, we're going to lose the stream. But if we trip the GFCI, we should be just fine. Okay, we're going to plug it in. Let's see here. Okay, we are energized. Blue light is on. Blue light. And if the blue light is off, it looks like that. So blue light's on. Looks like that. All right, this is what we're going to do. So we are energized. Blue light is off. I've got a red light on my GFCI indicating that it has power. We're going to reset the GFCI. We are now loaded. We are going to plug this in. Okay. What do we have? Go turn the plug tester on. Says we are correct. What I'm going to do, I'm going to trip this GFCI right now. And it's going to do its normal cycle. And it's going to think about what we just did. So we're going to trip it. Now it's going to flash a couple of times, as it should. I bet you it turns red. No, it's not going to turn red. I bet you it's going to... Oh, it did turn red. Okay, so we need to figure out why it turned red. What does it say? It says 30 volts. Is it possible that this GFCI itself puts out 30 volts because it's got a red light indicator? Or not? Because inspectors need to know this. If you're an inspector and you got one of these plug testers, you're going to be really confused like I was. So now we got to figure out, is it this light indicator that's giving it a backfed neutral voltage? Or do these GFCIs just show red on the Klein tester? Because that's not a good look whenever you're trying to do a final at a restaurant, I promise you. So let's turn it on and see what happens. Let's do this. If we were to turn on this light, what happens? Nothing. Because we're on the line side, so the GFCI is not sensing. If we were to switch the hot to the load side, the GFCI would trip because it's going to sense a difference. And that's basically how GFCIs work. They say, hey, wait a second, where did this other amperage come from? Or I have a change in my amperage because there's little CTs inside of here, and they know to turn off the circuit. Let's wire it correctly and see if we get 30 volts, because that's interesting. Okay, we're unplugged. You can see here this thing's just going to say off or something. It's going to stop because it's got its own battery. There you go. Okay, so power's definitely off. I got the cord unplugged. There's no point in doing the theatricals for showing you that it's not energized. It's simply not. What happens if we wire this thing correctly and we don't have anything plugged in here? It's still not wired correctly, but I want to see what happens if nothing's plugged in here. Is it Klein's GFCI tester? Okay, we're going to trip it again. Is it going to read red? That's the question. It might be the GFCI, guys. This is a huge problem for Klein. They got to figure this out because they can't be showing a red light. Because not all GFCIs show a red light when you trip them. Let's unplug it and not wire it crazy. Wire it properly, and let's see if it shows red. It's unplugged. Very interesting. Wasn't even trying to make a decent joint. Just can't help it. Okay. Yeah, the ideals are really hard to get out. Even when they're open, they're still hard to kind of pull out, which is something that I really like. Look at that. Look how hard you got to pull to pop the ideals out on number 12. They just grab amazingly, man. Versus a Wago, I think I got a Wago here somewhere. I'll show you. Don't have a Wago here right now. Hold that thought and I'll show you guys a Wago. Okay. The only thing we're gonna do here is strip this back a little bit further so I can get to my ground. This knife is super dull. Remember, you need 1/4 inch of sheathing inside of your box. We're gonna go ahead and put in our bonding screw, as we should. Actually, want to go this way because the screw is going to tighten it. We wrap it around. There we go. And I'm going to get my favorite pair of strippers. You guys seen the Klein V cutter? It might be a gimmick, but it's interesting. No, it's not Klein, sorry, it's Racketeers. You can slide right up the Romex. We can try that. We got the Romex here. Let's see here. Got the Romex here. And if we slide up here, it's got a little, see the knife or whatever down there. So if we slide up the Romex, let's see what happens here. Doesn't seem like it wants to slide right now. Hang on. Hang on. Works enough to start some Romex. Should have used it on the box. That'd have been cool. All right. GFCI. All right, here's the deal. We have the proper industrial cover, which is right here. And what you would do is basically unscrew these nuts here. And then you would pull all of these screws out and you would put these bolts here through here, and this would look like really pretty, like this. And then you'd wrap it with tape, you know, and all that stuff. We're just gonna not do that because I'm gonna open this back up for another experiment in the future. So I don't think we're gonna install that. Thought about doing it, we're not gonna do it. We're just gonna land these in and check if Klein has a problem, or does this GFCI have a problem. And the only way to know if the GFCI has a problem is by checking to ground the neutral voltage. So we're gonna land, let's do this, let's not land the ground. Let's not land the ground. And let's see what this says. It should say open ground. We're plugged in. It's hot. Plug this in. Turn it on. Should say open ground. But does it say 30 volts? It does say 30 volts. Yeah, it says 30 volts AC. Maybe it's this GFCI that just shows 30 volts. Let's hook up the ground. This is kind of like whenever Eaton came out with the GFCI, AFCI dual function breakers, and then all of a sudden we had to hold them for like 2.5, 3 seconds for them to trip. And as an inspector, man, we were just pushing the button. You used to just push the button real quick and go down the line of the breakers to check, dual function protection or AFCI protection when you're doing an inspection. And lo and behold, the new style breakers, you got to hold for like 2 seconds for them to trip. Well, we thought that they were bad breakers. Okay, let's turn on. So let's reset it. Oh, we gotta open it up. There we go. Okay, so we got 117 volts here, and then when we test it, it's gonna say fault. So this GFCI, I think, is a problem. I think the GFCI is the problem. Let me unplug this real quick. Or, well, let's do this. Let's check. Let's check how much current is coming out on the neutral. It's got a little indicator light. Let's see if we get any current on the neutral. We can go to amps right there. AC, that's what that symbol is. And then we're going to select, with the selector here, we want amps AC. Yeah, okay, we're at the right setting. 0 on the hot, which probably means 0 on the neutral, actually. 0 on the neutral. I don't know why it says we got 30 volts to ground. It's kind of weird. Let's hang this here so you guys can see it. And we're going for volts. So we're going to go volts. Make sure we're at the right voltage. AC volts, okay. And we're going to check the hot to the neutral. I don't know why it's doing that. It's let me try that again. Volts AC. Getting 116.3 there. Hard for you guys to see. This is why I didn't want to hook up the ground to the box, because I risk bumping this into the box and exploding something live for you. And right there's the neutral. So we got 116.4. Let's go neutral to ground. We've got 2 volts. Let's see here. 0.207. 0.2. Here's the thing with Ideal and these ranging meters. This is why I don't like Ideal, is because they tend to fluctuate like that. This is why I like my Fluke. Let me go get my Fluke so we can see a single non-variable number. It's one of the best things about Fluke. Doesn't give you any decimals where you don't need them. Doesn't try to range. It just works. So for this, how can we do this without, oh, I know what to do. Okay. Can we see the volts? Make a little multimeter caddy there. Yeah, perfect. Okay. I'm gonna go to the hot to the ground. And we've got 117, no decimals, very nice. Let's go to our neutral here. That is grounded neutral, and we're getting 0 volts. And yeah, ground to ground's obviously gonna be 0 too. I don't know. Let's take this GFCI to something that we know works. Sometimes it's the branded GFCI that shows a red indicator 30 volts even when it's being wired correctly. I found that multiple times in home inspections. I don't like it. I appreciate that. Okay, SerDes. No electro, just IT, and often run low volt. I'm going to check the chat here in a second. Yeah, if we go here to this receptacle, that's GFCI. Oh, there you go. There's a nicely installed GFCI. If we trip it, turn it on, and it's gonna be backwards, so I think it's this button. We trip it, you can see the lights turned off because we lost a little bit of light. It's gonna do its thing, and it's not going to show a problem. Yeah. So it's that particular GFCI that does it. So now we need to go find a different GFCI tester and see if we can see maybe a flickering light or a faint red light from the GFCI itself. I'm going to take you with me to the car because I've got so many testers, it's unreal. I think I probably buy one at least every other month. Because I'm always losing them. So let me see here. I got some Milwaukee strippers. Oh, there you go. This is great to have for inspections, man, because you get the full carousel where you got your choice on what you might need, and then you've got the 5/16. Eaton makes some panels now that I freaking hate because they have 5/16 and square only, no flathead. So when you're trying to open a panel, the guaranteed satisfaction used to be a flathead. Like if you had a flathead screwdriver, you were guaranteed to find. See, here's the freaking box, but can I find the plug tester? Probably not. Probably not. Let me see here. I've got a bunch of business cards and stuff out, so I don't want to dox myself here. If not, I'd let you guys see more. Dang. Dang, dang, dang. I don't know. I guess I lost another plug tester. Look one more spot. Look one more spot. Nope. Yeah, see, I can't hold on to plug tester to save my life. It's like, it's impossible. I got something interesting from UL. If you guys ever want to see what UL looks for, here's a spreadsheet here. Or not a spreadsheet, but I got some papers. When we talk about stuff being listed, And what they do, I ran into some equipment that did not have a listing. And they ended up having to go, you know, to UL or ETL or whatever to, let me unplug this. So this is something that they look for. This is a UL document here. This is their proposed test plan: protection against live parts, heating, leakage current, moisture test, IP4X, which is the type of enclosure. All the gear with no idea. Yeah. Stability, mechanical hazards, mechanical strength, construction, internal wiring components, supply connection, provisions for earthing, screws and connectors, and then some other stuff there. Resistance to heat and fire, things like that. So yeah, I guess I lost another plug tester. No shock though. I'm always buying a plug tester. So I've got this one. Hey, we've got this one. We've got this one. There's a reason why this one never goes to my car. I'll lose it in a second. Let's plug it in. Okay. We got red lights. I'm actually going to turn off this light. Got to reset it. Okay. And we're going to trip it. And we don't get any faint light. Like there's no light on at all. So is it Klein's tester or is it the GFCI, man? I don't think Klein's tester should show red. Why do you always fail your inspections? Man, more than 80% fail. That's actually a pretty accurate number. I see a lot of crazy stuff. I see somebody with potential, you know, I kind of wait around and let them fix it sometimes. Or if it's something you can't fake, like if it's like a jumper from the ground to the case or whatever it is, you know, if you can't fake the picture, I'll let you send me a picture once I've already been on site. You think it's the GFCI? I don't think the client should be showing red when you got a fully functioning GFCI here. And nothing wrong with it, but then it says 30 volts. They shouldn't do that. I'll tell you that, because that just wastes people's time. Luckily, at that place that I was at, they didn't put bonding bushings on their rooftop units or, you know, have any of their AC nameplates matching the breakers and stuff like that. Because I've failed this place for GFCIs that do this one too many times. So it seems like this tester is a problem. But in general, you know, if the power's off, you shouldn't see that anyway. So maybe it is an okay tester. I don't know. What the machine do? It's a GFCI. It senses differences of current and then trips the breaker. Is Klein my go-to? What's my toolkit for networking? Man, I don't do a whole lot of networking, but I've used Klein in the past. I don't really have very much networking tools at all right now. But yeah, the Klein crimpers and stuff, they work okay. All right, let's check the chat. Triples for every tool with, yeah. Are you qualified? You should qualify. Yeah, we're definitely qualified. Like to touch troubles with your tongue? All right. A great beard. It's tricky, man. Sometimes it grows like a certain way and then you just don't like it, but you don't want to trim it. If you're trying to grow one out and it's not growing like uniformly, don't trim the side that looks bad. Just wear it bad for a couple of days and then let this side get a little bit longer and then try to, you know, never trust the inspector. Yeah. Yeah, he'll fail you when your GFCI turns red and then stop the job. Fiber's no fun. No, I don't envy you in fiber. Let's see here. I might have missed a couple of the chat. Might not matter though. Let's see. The client auto ranger still had manual range. I had to scroll through 3. Yeah. I appreciate that, Josh. I had to scroll through 3 propaganda channels for getting here. Nice. Neutral there should be 0 volts. Yeah, it was. That's good. What am I trying to diagnose? I was trying to check out the GFCI. It's not showing the correct thing. It shows 30 volts. Nice, Peter. And yeah, so I would say it's the GFCI that shows it. So if you have these GFCIs, this is them. Where's the box at? That's cool we replicated it because I wasn't sure if I could or not. I gotta find the GFCI box. Because I'm an electrician, I'm checking the floor first because that's usually where everything goes. You just throw it on the floor. But I don't know. It's possible that I opened it while I was walking. Let's see. No. Damn electricians. Just any verifier TDLR to save so much trouble time. Clients will love you for having that report. Just any verifier with TDR. Hey, can I ask someone's opinion? Should I do 4 years for electrical engineering and get my bachelor's? Or really doing and learn through there and work on projects on the side to earn more? Man, that's a tough call. A lot of engineers need field experience. We have a lot of engineers right now that don't have field experience, and it kind of shows. Now, that being said, I wouldn't know half of what I know if I was not an electrical inspector. So there's not very many good electricians out there. There's really not. So we need both. What circumstances would you not want a GFCI? Oh, my freezer in the garage. They made that a code now. So you got a GFCI protection in your garage, which, don't get me wrong, GFCI protection is a great idea. But I don't want GFCI in my garage. Especially on my freezer. What state? I'm in Texas. So this is the GFCIs from Lowe's. They are Eaton. And the only thing that I see different is they have a little red indicator light right here. Right there. But when you hit test on this Klein tester, it shows red as open 30 volts to neutral, which this was my suspicion, was that there was like a backfed neutral. So we were trying to do like a backfed neutral scenario where we had current on the line side of the GFCI, which wouldn't be a good idea anyway, because you share neutrals and then you don't have a handle tie on your breakers. So anytime you share neutrals, amongst circuits, you should be able to simultaneously disconnect. Ground fault current indicator, ground fault circuit interrupter, GFCI, sorry. So, do you do your bachelor's? Man, that's pretty solid. I'm not going to tell you to not do a solid career, because an engineer is something that's very needed. I would say that you definitely want to get, some trade, hands-on experience. If you go to the trades and study up there, you're going to learn a lot of stuff. You're going to learn a lot of stuff that can't be taught. You're going to learn moral integrity. You're going to learn doing the right thing when no one's looking. You're going to learn how to really work as a team. You're going to learn that pretty much everyone's an asshole. It's going to be fight or flight, man. You're going to be in the worst environments. You're going to build character and fortitude that you can't build in an office. And then you're going to be able to work on your own house, which is huge, because you can buy fixer-uppers. So the stuff that you're going to see is going to motivate you in ways where you're going to save a lot of money. You're not going to make a ton of money like an engineer, but you're always going to live a comfortable life. I don't know the engineering side of it. I know you can make a lot of money. You're going to be in an office. You're going to be looking at plans. It's a different lifestyle. I'm really happy with the route that I took. Ultimately, I became an inspector. I worked for the same electrical company for 10 years, and before that for others for a couple of years, but I did a lot of industrial. I did infrared. I've done a lot of different things, built hospitals ground up, all kinds of stuff throughout my career. Now I'm an inspector. So I would say, man, if you got the chance and you got the ability, do the engineer thing, but definitely get some field experience. Let's see here. Looked into taking apprenticeships since seeing that initial toner video. Help broaden the skill set. Yeah, I appreciate that. Just call somebody. Are you hiring? There's a lot of trade schools, especially here in Texas. There's a lot of trade schools that it's shaped like a union, but it's not a union. It's an apprenticeship program. But they will find you the contractor, and then they'll log your hours, and then they're going to guarantee you $1.50 or whatever every 1,000 hours for the next 4 years. So you got 8,000 hours that you're there for. Every 1,000 hours, every 8th, you get a pretty substantial raise to where you're making some pretty decent money, especially if you're young. If you're older and you already got a family, that's hard to do because they want to start you off as low as possible and then you work your way up. If you got some experience, you can probably start mid for your company, but the school is not required to give you any money. They're going to say, we're going to start at, let's just say, we're going to start at 15. We're going to start at 16. And then every 1,000 hours, we're going to give you $1 more. So as you progress, you get that $1. If you work for a company and then they put you through school and your company starts you off at 20, you might not see a raise for a while because they don't have to give you any more money. The school requires them to give you more money, but most of the time the companies, take care of you and they give you raises anyway. But in general, you start off as low as possible, and then that company purposely works with those schools because they know they can get a better rate. So they hire you for cheaper and then work your way up. And the whole time you're learning how the company works and how you do things and all that stuff. So that's the way I started. $70K in Tulsa as an electric engineer. I can tell you right now, I make 34 or 5 an hour doing what I do. And I'm an electrical inspector. And my office is my car. and I might go out, I might see 20 job sites that day, and it's really relaxed and it's a good environment, and that's it, you know. But you see a lot of stuff, you got to do a lot of conflict mitigation, and you better damn sure know the code book. It's a good gig. So, but not everybody can be an inspector, you know. It's kind of hard to get the job. I'm really grateful for where I'm at. I wouldn't trade it for anything, but I could make a ton more money not doing this. Let's see here. Not an engineer or designer. Oh, I see. So about 4,200 in raises a year above your base pay per hour. Every 1,000 hours of logged work. So 40-hour week would be 40 hours. So 1 week would be 40 hours. They're not going to log it like, you know, what you're actually working, and usually overtime doesn't count. You're there for 4 years. They got you. So, yeah. Yeah, they got it all figured out. My age was kind of scaring me away from trying further to educate, to be honest. I didn't want to continue my education just to not find work again. The good thing about this trade, man, if you got integrity and you got a work ethic, you're always hireable. You're already a step above half of the people you work with. Just have those two things. That's all you need, those two things. Integrity and a willing to work. You know, maybe a willingness to learn is a nice benefit. But if you got those two things, you are already ahead of the competition in spades. What's up, Vishal? Thank you. Average person works 2,080 hours per year. 2, 4, 6, 8. Yeah. Mark your calendar. Solo purchase a rigid today. Nice. So basically, a contractor. It's the bidding wars that become a nuisance. Yeah. Thank you for your time, share your experience. Appreciate it, Insomnia. I have a family, but a lot of low volt experience. Not sure how else to get the on-the-job time experience with the high voltage stuff. Call a local electrician, man. Just tell them what you got. A lot of the low volt guys, you've already got the muscle memory. You've already got the know-how on how you're going to route something. You've actually got something better than most electricians don't have. You only learn this as an electrician from pulling a lot of wire and either watching somebody completely jack it up or messing it up yourself. But you already know how to lay out cable, you know. I see a lot of people, and like MC bundles and stuff like that is designed to be pulled from the middle, right? I see a lot of people that will start unrolling wire off of a spool in circles like that. And then when they drag it down the hallway, it's all twisted, you know, instead of like rolling it. You might have a roll of wire with tape around it and they'll pull it out from the middle. It'll look like a slinky. Being low volt, you're already ahead of the battle for pulling wire, I'll tell you that. Most people jack that stuff up so bad. How have I not figured out how to do all the comments? Because, dude, I have not taken my ADHD medicine in 3 days because my stomach's been jacked up. So I'm trying to figure out what's going on, man. I had mold toxicity poisoning, and it's wreaked havoc on my body. So it's just been rough for the last year. I now have all of the comments up. Oh my goodness. Why does YouTube do that, man? What's up, Charlton? 2468. I actually have to do labor, though, if you weren't an inspector. It actually have to do, yeah. Let's see here. Let's see what else I missed in the chat. Thank you, sir. I need to do with Alzheimer's to remind me how to work the YouTubes. That's correct. I should be able to show you some pictures of actual work live, and you inspect it the best way you can live. That'd be cool. That would be cool. Electrician helper job wanted. We always call that somebody putting a-holes in. Yeah, exactly. Yeah, you got an asshole. That's exactly what we call it, too. You just show, hey, asshole, you got an asshole. That's awesome. What's some of the craziest things that people try to get past while you're inspecting? Let me show you. I'm glad you asked. Hang on. Let's go here to let's go to shorts. If you're curious, you can go to electrical mistakes to avoid in my shorts. If you type in electrical mistakes to avoid, you're guaranteed to find some of the best stuff. Show all. Yeah, so we've got, I mean, there's just so many. Probably one of the craziest ones that I've found, though, was they were missing the ground and neutral bond in the main switchgear. And you can't trip a ground fault without that for a whole apartment complex. No, I was not in the Army. Appreciate anybody that served. Anybody that served in the Army, thank you. Let's go here. We've got 307 videos. I'm going to turn this mouse on and scroll this way. Hang on. Should be that one. Nice. We're you in Space Force. Yeah, here we go. The worst part about this was that I almost missed it. Like, I almost missed this. It could have been really bad. I don't know what that beep is. I'm trying to find the video right now. Coming in late and new to your content, just curious, whereabouts you from? Idaho here. North Texas. That's 4 times. Super curious. Hang on. What's some of the craziest things? Okay, yeah. And you asked 4 times. Sorry, sir. One item that bugs crap in me is when utility says they're allowed 5% voltage drop at the service disconnect, and then they get away with it. One of the best things with utility, this is the rules of utility. I think everybody wants to know. This is why. Okay? When utility comes off of a transformer and they run to the meter and then they go to a 400 amp service here. Okay? This is 2 pipes. 2 pipes. Just one line is a pipe. They're allowed to run, like, let's say 250. Let's say they're generous and they run a 3. They're not going to run a 3-aught. What do they like to run? 250 aluminum. They might run a 250 aluminum here to this meter. And then our disconnect is 400 amps. Why can they run a tiny wire to the meter, but we have to run 2 sets of 3-aught, or we got to run, 1/600 kcml? Why is that? And that's because they don't land on overcurrent protection. They land on riser pads. So the rule is, if you land on overcurrent protection, now you got to pull the right size wire. What's that, Pips? Wondered that for years. That's why. They don't land on overcurrent protection. Okay, we need to find this short here. Let me see here. Some stuff is so bad, guys, I can't even put it online. Some of the stuff I see is like, I just don't even post it. But yeah, there's all the electrical mistakes to avoid. If you just type in there on the shorts. I'm gonna find one here. Let me go back here and I'll find it. I think I did a breakdown of it, of how bad it was. Is this it? No, that's not it, but that's funny. That's small stuff, man. That's just one house. What I don't like to see is the stuff where multiple families are involved. That's the worst stuff. Dang. A lot of videos here. My phone sure does like ringing. This one here. This one here is pretty bad. Okay, so this is right off the transformer. That's 1600 amps. That right there, that's the jumper that attaches the grounds to the neutrals. And then look at the lug. You can see the uniform spacing. And then all the wires are loose. That's the UFER. That's also the UFER. You can see the spacing when you line it up. All those are loose. You can see the size of the wire. I think it's 600, 340 each. So that's going to be 500 aluminum, I think. So just incorrect installation all the time, man. But that thing right there, that offset bar bolts from the ground to the neutral. So when we look at a ground to a neutral situation, if we look at a ground to neutral situation, I guess we're using blue. Right after I get off of here, I'm gonna make a clear whiteboard with black background, and I'm gonna use glass, and we're gonna use like neon pens, and it'll be black with neon markers. It should be pretty cool. Make it out of plexiglass. Minimum number 6 bonder. Not on that size, man. That structure was a apartment complex. Very nice, huh? Okay, so. Ooh, that is my city phone. I have to answer that. I am on call. That phone ringing is not good. Hang on. Oh, it's good. We're good. Okay. No, not quite 911. Someone probably just losing power. Okay. Transformer here. And on the transformer, we essentially have this inside of it. We have a neutral there. We have a 120 volt leg. And we have a 120 volt leg. Now these two together gives us 240. Line to line. So if we take our multimeter, we're going to get 240 here. And then one leg to the neutral is going to give you 120. Man, I'm getting a lot of calls. The plexiglass marker stuff. I just want it so it's like not so just bam, you know, it's just, this thing's like too white when you're walking in and you're looking around here. You know, I haven't even shown you the whole layout of this area. It's kind of cool. 208. 208 is on a Y. Hang on a second. Hey, I got two phones in here that's ringing way too much. Five. Oh, that's my brother trying to call me. Oh, huh. He says, "Can I talk with that picture?" I think we should talk. Hang on. Hey, I'm live on the phone right now. Do you want to talk about your electrical? I'm live, but people would like to see what you got. It might be that interesting. No, you don't have to go down here live. Just talk about it. I can draw it on the board. What do you got? Can I put you on speaker or not? Okay. Nice.
Yeah.
Okay. Go ahead.
Alright, so I got 3 black wires, one coming in from the bottom, which I believe is the load. I have another black wire that's coming in to the top, which feeds something, and then a third black wire that might feed something else.
Okay.
Picture.
Okay. Right. What about it?
What is the top 2 on? One on the right side at the top, I assume, is a feeder.
So you got a multimeter or a hot stick?
Downstairs, not with me.
With the power on and everything disconnected, if you take your hot stick to the wires with everything on, like the power on, but everything is disconnected, that's going to be your constant hot.
The top right should be my top, constant hot.
You never know where the electricians are going to put them.
I know. That's why I'm calling in.
Well, that's how you find out which one's your constant hot, is it, because everything, you got to disconnect everything, unfortunately, to find out what it is. Hang on a second, let me see. So you got, trying to get your name off here. Okay. So you've got a switch. Is that backstabbed? You're going to wrap around the screw. You got to connect the grounds too, as well. Okay. So turn off the power, okay?
Oh yeah, power's off.
Okay. Cut the bottom black wire.
All right, we can do that.
And then, what are you trying to figure out here?
So what I'm doing is, this is actually a fan that always stays on because my kids will just let the fan keep running. So I'm actually putting in a timer switch, 10 minute, 20 minute, 30, 60, whatever, right? It's formed, so my fan will automatically turn off.
Okay. It's a fan rated switch, right? Motor? Probably not enough load. You're probably okay.
Yeah, it's just a bathroom fan, right?
Okay, well then, what I would do before you cut anything. Did you already cut it?
No, not yet.
Okay. Make a pigtail? Like, you watching my live?
No, I'm not watching it live.
If you watch the live, you can see what I'm drawing.
Well, you're going to have to give me like 5 minutes to get into your live sooner.
You got 2 wires coming to the top of that. Make a pigtail. And then, yeah, exactly. Yeah, make 1 pigtail and then run 1 wire off of that. And then I'm willing to bet that the one on the bottom of the switch is your constant hot.
Yeah, I'm willing to bet that as well, but all of my wires are coming from the bottom, so it's not like I can discern like this is a true hot, or just from the wiring diagram.
Yeah.
The wires come from the bottom, and then they run up to the top for whatever your lights, your fans, whatever it happens to be. But everything's coming from the bottom, so I'm having a bit of more of a time figuring out what's the load and what's the
right. Those two, it's a light and a fan, right?
Well, that's the thing. It actually only feeds a fan. There is no secondary on this, which is
okay.
Part, right?
Okay, scratch that. The two coming in are your hot. One's going to be from a plug or something. One's going to be going to feed. Whatever's going on. I think the two are hot now. And then the single is your fan.
Okay, so if that is the case, I've only got if you look at my second picture, I've only got a line and a load. I don't have the ability to split this off, right?
Right. You're going to make a pigtail on the two. Either way, you're going to do the same thing. I'm just going to change which one I think is a constant hot. So yeah, just take your two wires, make them one, right?
Okay.
And then just connect it accordingly, just like you see it.
All right.
And the two should be your line, but if you really want to verify, you could cut that off, like just cut all your wires.
Okay.
And then strip them. That way you can get access to the copper.
Yep.
And then with the power back on, have wire nuts on all three wires.
Oh, come on, I can't hold them all at once.
I mean, you can tap it on and off if you want. I was gonna say, if you want, you can turn the power back on and start just touching wires to wires. That's what I do. But what you can do, just have wire nuts on all three of them, right? Get your hot stick, figure out which one is your constant hot. That's going to eliminate one of your wires, right?
Okay.
So we're going to separate our wires. You got three coming in, and we're going to identify one of them by figuring out which one's hot with the power off. Once we find the hot, you're only left with two more wires. I think one of them's probably going to go to something else that's constantly hot. And then one of them's going to go to the fan. So if you touch the two wires together, that's your fan, with a wire nut, you're going to turn off the power. Once you figure out which one's a hot, turn the power back off, and then jumper the hot that you know is hot to the fan wire, and the fan turns on. Then you'll know that that's your switch leg.
Oh yeah, sounds wonderful.
Yeah. And then your other wire goes back to the hot, and then you'll wind up with a pigtail and then a switch leg from your hot.
All right, well, I'm going to go downstairs and turn this back on and validate on everything.
I just drew it real time live. If you go to the channel, you can probably find it at 1 hour, 23 seconds, and 38 seconds. It's 23 minutes and 38 seconds in. Oh, the chat says to lick your fingers.
Okay.
Oh, someone says also you can check it with the meter. But your neutrals, does that switch have a neutral for it too, or not?
That switch does have a neutral, and they actually have a ground, but none of them are connected to the switch.
Does your new switch have a neutral?
It has a neutral and a ground, yeah.
Okay,
I'm
so
gonna actually put those together. I'm not together, but I'm gonna put them back in line to actually have them there versus what was there.
yeah, so your neutrals can just get pigtailed to your new switch, right?
Yeah.
And then your I already drew that hot. And then your ground gets attached and pigtailed. And then your switch leg goes to the other side of your switch, which usually it's opposite. I don't know what your switch looks like, but you're probably going to have a hot and a ground, one on top of each other. You probably have four screws, or is it wires?
So I have 4 wires.
It's
right
wires.
Now, on the new switch.
Right.
But if you look at the diagram or the picture I sent you, you can see what I have for new. which doesn't seem to discern line and load on either side. They're both actually labeled line and load.
Yeah, I took a dimmer the other day. It didn't matter. So, yeah, most likely those two in the top are going to be the constant hot. The one at the bottom is going to be the fan switch leg. And then you pigtail your neutrals to one neutral, and then definitely get those grounds landed.
Yeah, well, give me a minute. I'm gonna do a little testing here. So I'm not using my tongue.
Yeah.
As much fun as that would be, I will pass on that.
So, someone wants to know, how come you don't have any electricians in your hood?
I don't know.
You got one on standby here.
I mean,
Yeah. So.
valid power, making sure. Testing another switch to make sure I had valid power somewhere.
Yeah. I'm gonna talk about it one more time as I draw it, and then that should get you.
That's fine.
You got 3 wires coming in. You want to know which ones are hot. Turn off the power. Check for which one's energized. Once you identify it, put a wire nut on it. Then go turn the power back off. And then jumper one of these wires to this wire nut that's hot. And then you'll be able to find which one's your fan. Once you've identified which one's your fan, then you're going to tie these two together with a wire nut. You're going to make a pigtail for a constant hot there. That's going to be hot. Then you got your fan, and then you got your switch. The hot goes on one side and your fan goes on the other. And then don't forget to land your neutrals and grounds if you got them. There you go.
Alright, so the top right is my load.
Top right.
Yeah.
Okay, yeah. It is?
So I got 120 to that. The top middle also.
Chances are, because you have so many Romex, you probably actually have 2 Romexes going up to your fan. And since it's only a fan, you don't have a light, they probably just tied both of them together in the ceiling. And maybe both of those Romexes are actually switch legs.
Yeah, so just for edification purposes, the bottom is my switch load, and I have 2 loads coming in from the top.
Whoa. The bottom's your hot.
No, my bottom is my switched.
Okay, so the top right is your hot then.
Yeah, and so is also that top middle.
Hang on. You got other pictures? Hang on.
Got a picture.
Hang on. Oh, you're talking about your switch.
Yeah, the actual switch.
Oh, yeah.
Both of those are hot.
Yes.
So I pigtail both of those together.
Hang on.
Yeah. Now look at the second picture.
I was looking at the second picture.
Oh.
Yeah, I got you. Yeah, the second picture. Okay, go on.
So the second picture, I've only got a load and a line out on either side, left and right? The black.
Yeah, one's constant hot, one's your switch leg.
Right. So what do I do with a constant hot when I have 2 of them that are hot together, and I've only got 1 load side on the new switch?
Tie them together. Tie the 2 hots together and make a pigtail.
That's fine. I just wanted to make sure before I threw that, together, right?
Yeah. Cool.
All right, so I can tie them together. I will pigtail that and go for that.
Yep. And then at I didn't timestamp it, but probably an hour and 29 minutes in, go to an hour and 26 minutes in, and then I drew it exactly what you want to do. Okay. Catch you. Love you. Bye.
All right, love you, bud.
Don't need a pigtail. Probably not. He understands the word pigtail. So we're going to roll with it. Okay. That was fun. Properly label each wire. Yeah. Yes, that's how you get your voltage, okay? So that's how that works. Let's see here. What happens when we don't have a neutral? You'll notice there's no grounds from on-course transformer, or not on-course, from the utility transformer, right? So there's no, we're gonna leave the neutral as blue. We're gonna have blue. And we're gonna use this as the case. So the neutral comes in and it hits the neutral bar, right? Your hots come in, and we're gonna jump over here. Your hots come in. We almost drew something there. That could have been bad. Demonetized. Okay. Hots come in to your main breaker. Whatever. Your grounds are now born at your first means of disconnect. Your grounds only exist to get current back to the neutral. There's your ground. If we have a receptacle, in a box here, and for the purpose of this, we're going to show the grounds here, and we're going to show the hot coming from a separate breaker that fed the receptacle. I'm not going to show the neutral to the receptacle to keep it simple. Okay. When we get a fault on the box, the current gets on the ground because we bonded the box properly. So we have a fault here, short, not short, ground fault. Current gets on the ground here. Okay. The current needs to get back to the neutral. This is why we have the bonding jumper. Thought that was a green pen. This is why we had the bonding jumper at the first means of disconnect. Because now we can get that current back to the source. And how do we do that? It goes back through the neutral. And it goes through the windings of the transformer and comes back on the hot. And it goes through the main breaker, and it goes to the source breaker because that was the source of the fault, and it sends all that fault current to trip that breaker. And that's how it works. That has nothing to do with the earth. When you trip a ground fault, it has nothing to do with the earth. So back to what I was saying, this jumper right here, this jumper is, wait for it. Wait for it. Got some loose wires there. Real loose wires there. Oh yeah, there. That right there, that loose thing that's not connected. That's that. So by far, probably the worst thing I've ever seen. Honestly, I've probably seen worse, but that one was pretty bad recently. Okay, that's all I got. So we replicated the 30 volts to neutral on the trip GFCI. So if you guys just got in here, I will do it one more time. We got to find it. I think that it's out here. Okay. This GFCI right here, this tester. If we plug it in, and we reset the GFCI, and under normal conditions, we trip it here. You're going to see that we're going to get a fault of 30 volts. Right there. And if we do the same thing with a different plug tester, we don't have that issue. If we do this with a different GFCI, this doesn't have the issue. So it's this one particular GFCI that shows a 30 volt fault for whatever reason with this tester. Yeah, the outlet's grounded. This one's probably, if you go back to the beginning of this, man, we tried to wire this thing wrong 3 different ways. It's this GFCI that does it. So if I go to another, let me find the box for you guys. I lost the box again. I can't hang on to that damn box. There it is. This GFCI here from Lowe's, it's Eaton, and this right here shows that 30 volts. Ground fault circuit interrupter, GFCI. So if we go, let's go here, and we turn our tester on, and we hit test, and you're going to see these lights are going to turn off. And we let it do its thing. It's not going to have a fault. So it's a combination of that GFCI mixed with this tester that shows a fault of 30 volts. So if you are an inspector like me and you failed some jobs because they showed this after you tripped at maybe a commercial project, a kitchen, something like that, whoops. Whoops. I don't know what the solution to that is. I feel like Klein shouldn't show 30 volts on this if there's not. Or I feel like this GFCI shouldn't be allowed to something. Someone's in the wrong here. I don't know who it is, but it's very confusing as an inspector. That's like the equivalent when they started putting WR rated receptacles in clear writing and white writing and gray writing instead of blue like they've always been. And then we're going to job sites and we're like, oh, no WR. That is a recommended outlet tester. I don't like this outlet tester. For inspections, it's very slow. If I'm doing an inspection here, right, and I hit this button, I have to hit this button immediately to see the result. And then when I unplug it, sometimes it flashes for a little bit, and then I got to hit this button again to reset it. And now I can go and test again. It's very slow. This tester here is quick. Pop it, GSI pops, go to the next one, click it, go to the next one, click it, go to the next one. So for a technician or somebody, this is nice. But if you're an inspector, these quick ones is where it's at. If you trip a lot of GFCIs, if you're doing a lot of apartment complexes, doing a lot of QA/QC, even if you're just doing QA/QC, you probably don't want this guy anyway. See how quick it is? No flashes, no extra buttons to push. This is the one to get if you're an inspector. And then this is just confusing, the way that they got it, because it says it's correct and then it's not. Had a Klein voltage tester that showed 120 is 208 volts, started out of nowhere. Interesting. Maybe it's old. I go through so many of them, man, they're all brand new. Like all my testers are less than 6 months old. They break so often, I go through them all. Let's see here. Thank you for answering the question. Yeah, no worries. Pretty new and hardly used. Return that crap. Return that crap. Okay, well, that's all I got. We got a lot of people in the same community that probably want to do a live too. So we got a lot of the same subs, and appreciate all you guys' support. Our community is awesome, by the way. If you're new here, we got a really good community. We don't BS anything. We tell it as it is. And if that hurts your feelings, we're just going to make fun of you. So let me know what you guys think in the comments below. Thanks for watching, and we'll see you guys later.